I want to start this talk off with a show of, let's say, virtual hands. So, have you ever worked with a React component that was just particularly bad? Have you ever written one? Well, if you didn't at least mentally raise your hand right now, you're not just lying to me, you're lying to yourself. But what is this concept of a bad component? We had this intuition about how it makes us feel, but what specifically made that component you just thought of so bad? I've tried to come up with a few main categories of terribleness. The first and most obvious sinner is when the component's API, its props, it's either too complex to understand, badly named, or a combination of both. If your API doesn't make sense, it's extra frustrating when there's no documentation to explain it to you. Or even worse, if there is some, but it's out of date. If you've been so unfortunate that you've had to fix a bug on one of these bad components, you'll probably turn pale by looking at how it's tested, if it's tested at all. Complex components make for complex testing, which in turn leads you to silently skip that part. And if you're adding a feature or rewriting your components to use hooks, you're probably in for a treat. Hundreds or thousands of lines of code jump at you that you have to change, and making sure it's impossible to do a single character change without breaking at least 20 tests and definitely dropping IE support. What you're left with then is a pretty poor user experience. Not the end user, they might not notice a thing. React is cool like that. But the user that matters in this context is you, the developer. It's important to feel compassion for your fellow developers and write code that they will find easy to work with. So how can we turn this frown upside down? We're going to explore what makes good components good and how you can write React code that your colleagues will love. Code that you will love in a few weeks' time. Oh, by the way, before we get into this, I'm Kristofer and I work for Beck here in Oslo, Norway. I've been writing React apps for most of my career, and I can tell you right away that all of the tips that you'll receive in this talk is earned the hard way. My colleagues will probably tell you that I've learned them through repeated failure. First though, I want to dive into this term, compassion. It's one of those words I struggle to define. To me, it's that feeling you get when thinking of how others feel. The most formal definition is co-suffering or feeling for another, but no matter how you word it, it's about putting yourself in somebody else's shoes and envisioning their struggles. Showing an interest in other people's well-being is part of most, if not all, cultures and religions. Understanding how people's struggles and hardships can be a powerful emotion and a catalyst for change. Most people have probably felt some sort of compassion for the situation currently unfolding in the US. We try to understand how African Americans feel when they are being systematically targeted, harassed, and abused. Some help out by donating, spreading the message of equality, or protesting for their cause. But all of this is driven by the compassion for people in a hard situation. But how does this all translate? How do we apply this very, very emotion-driven concept of compassion to React? Well, my claim is that code is communication. When you write code, you're transmitting your intent to other people or your future self. The people reading your code want to understand you, but for optimizing this communication flow, it's something that we rarely do explicitly. Again, leading to intent being lost in the translation. The componentization of front-end code is making collaboration easier than ever. You can create custom hooks and complete UI pieces and ship them off as an NPM package in minutes. That also puts an added importance on this developer-to-developer communication. How do you onboard users to your open source library, for example? How do you make them feel it's a good library to use? The way we communicate is different from our day-to-day communication too, because instead of words and body language like we are doing now, now we communicate through props and docs and test cases. Writing code that other people will love to use, work with, and extend is hard, but it's what I call compassionate. And creating components that takes other people's needs and wants into consideration, that's what I call compassionate components. So, so how do we get there? How do we show compassion to our fellow developers through our React code? Well, first we need to figure out what makes good components good, and in many cases, it's the opposite of what makes them bad. So, first, you want to create explicit and extendable props that are both intuitive and easy to use. You want to write extensive documentation that is easily accessible when you need it, and use tools and write tests that give you real confidence in your code, yet doesn't get in the way of writing or refactoring it. Write code that is easy to extend with new features as well, while still maintaining all the other traits of a good component. And those are the topics we'll discuss in this talk. Props. Back in the 90s, props were something people gave you when you looked particularly fly. Today, we use the term to indicate that data and functions were sent to our React components. Perhaps not as fly, but I digress. These props is the interface of our component. This is how we interact with it, or put in another way, it's the API of our component. We pass data in and we expect a result to show up in our browser or mobile app. So how do we create a nice API for our components? Are there any rules or prior art we can lean on here, or do we have to figure out what's important from scratch? Now, API design is not a new term. We've all probably heard it before. It's probably decades old. But we typically think of API design in connection to REST and SOAP APIs or some other data transferring stuff. But as it turns out, API design can be just as much about how you structure your interfaces between your components. When I did the research for this talk, I read some prior art on what people would consider good API traits, and we found a few things that most people agreed on. First of all is versioning, because stability is key. The more churn you have in your APIs, the more pissed off your users will be, because their intuition is broken, and they need to learn the new API and unlearn the old one. Make sure you have as few breaking changes in your APIs as possible, and keep each one as small as possible. Error messages, they're incredibly important because when there's an error, good information is key to fix it. So help users fix the problem instead of blaming them for doing something wrong. Developers are flimsy beings, and they don't like surprises. So make your API intuitive by following the best practices and naming conventions that apply to you. And most importantly, do things the same way across all of your APIs. And finally, minimize your API surface. The less surface your API has, the less the user has to learn. Expose only what you know that your users will need, and only when they need it. Now, these are good guidelines for REST APIs, but it sure seems like they would translate well for React components as well, right? So based on this insight and about 6 years of experience, here are my favorite techniques when designing the props of my components. First, I like to avoid Boolean props if at all possible. A Boolean is absolute in its very nature, and it doesn't lend itself to making extendable interfaces. Let me explain with an example. When you're creating your new fancy button, you might want to create different variants of it. Let's say you have a base version without any styling at all, and a primary button that you use for the really important stuff, like signing people in. Since Jsdoc has this really nice syntax for Boolean props where you can skip using the value, you'll just write a primary prop, which turns your button bright and attention-seeking in no time at all. A few weeks later, you're creating a new landing page, and those attention-seeking primary buttons needs a toned-down sibling. So you add a secondary prop, which magically makes all your buttons a bit more laid back. Still, we're all good. At some point, though, you're asked to add the CTA variant by the sales team, since CTA, or call to action, button needs to blink or whatever they do to make sure people buy your stuff. And this starts to complicate things because you're now pulling in a new naming category or strategy. Could a button be both primary and a CTA? You don't know. But you now have primary buttons and secondary buttons and CTA buttons. But technically, you can have all three simultaneously. There's nothing that stops you from doing this, at least not technically. And even if you know that the CTA button and primary button are two props that are mutually exclusive, the next developer to join your team might not. Instead, I suggest you use enumerated values in a string, like variant here. Later, if you want to add new variants, you don't have to expand the API with a new prop, just a new available enum value for the already existing one. This makes sure you don't allow for impossible states too, so it's a double win. That being said, sometimes Boolean props are the right tool for the job. Sometimes things are just true or false, and the concepts they describe isn't an expandable one. Whether the button is disabled or whether it's in a loading state or not, those could still be valid use cases. Just think twice before you decide on using a Boolean prop, because more often than not, you should be using enumerated values instead. One of my favorite things about React is how it makes it easy to compose huge apps from tiny building blocks or components, each with its own responsibility, UI, and interface. You should take advantage of this part of React. Make components that compose together. I'll explain with an example. Let's look at a modal component. Now, I know a lot of people aren't huge fans of this particular piece of UI, but I've encountered it enough times that I know it might be relatable. They often end up requiring tons of props though, since there are so many variations we need to cater to. Now, this is just a tiny fraction of what you'll see in complete modal libraries, and the list goes on and on. To me, understanding and learning this huge API is a really hard task, and I'd rather just not. It's not a very compassionate thing to ask your consumers to deal with, in my opinion. Instead, we can break things up into a modal's unique parts. And it has a few of them. The overlay, the faded out background, the white content box on top of it, the close button, perhaps a title, a content holder, and perhaps even a footer with some action buttons on it. And by creating small components that combine together to create something, you have the flexibility to create exactly what you want, if you want something out of the ordinary. Perhaps we wanted a version without a close button, or perhaps we don't have a meaningful title, or perhaps we wanted a pink overlay today. The downside of this is, of course, that this flexibility is a huge overkill like most of the time. Most people use complex components in the exact same way. Giving them this huge API is just going to be in the way or create a ton of tiny design variations, which we don't really want either. But what's stopping us from having both? Luckily, there's nothing stopping us from creating another component that just does all this boilerplate for us and combining all of these composable components in a predefined way. These components can cater to the 90 to 95% of use cases where we want a default layout or default behavior. And if you want something special, you can always break it down to the more basic pieces and roll your own. This is a great technique for a lot of different components, from buttons and drop-downs to product presentations and site layouts. My third rule of thumb when it comes to components and their APIs is to make sure I allow for semantics. When it comes to creating reusable components, you'll never have a guarantee or the full picture for what context they'll be put into. We could use divs to create all of our elements, I guess, but by doing that, we'll lose all the semantic structuring possibilities we get by using HTML to its full potential. So, how can we allow for semantics? Take this card component. It's a box that might have an image and definitely some content. There's no real semantics to a card, at least a generic one like this, but the way it's used might vary. Here, we might assume it's a div, but it could also be a part of a list and be a list item if bunched together with a lot of other cards. We could, of course, create two very similar components, like a div card or base card and a list item card, but that leads to a lot of code duplication and potential future bugs. So luckily, there's another way. By providing an as prop, we can allow the developer to decide the correct element based on the context it's in. This can be even more powerful too. You can send in other components that render your component. Think of your favorite routing library's link component, like React Router's link. We can make our card into a link card in a few characters of code. But how can we implement this? Here is a super basic implementation of a card component. It renders a div with a card class on it, and that's about it. So let's introduce that new as prop. Here, we rename the as prop to element with a capital E. This is done so that we can override what DOM element is rendered by our component. Note that if we don't pass in an as prop, we'll default to a div. We can also do this by deconstructing the props directly in the argument list, complete with renaming and providing a default value. Now, I know the syntax is trash, but it's one of those things you get comfortable with really quick for some reason. Now our component is completely adaptable to whatever context you put it in. And you can do the same with all kinds of elements. Cards can become whatever you want. Some buttons might need to be links instead. Your grid system might provide some extra content hints by using sections or articles in the right places. And you can create truly basic components that can be composed together with all the semantic meaning you need. You might have noticed, though, that my last example was somewhat flawed. I made my card into a link and provided it with a to prop to indicate where it should link to. But that prop was never applied anywhere. It just was forgotten about. So that wouldn't work. And think about more generic components like buttons or input fields. Do you even know half the available HTML attributes for an input field? I don't, and I don't have to. Thanks to my next tip, spread the remaining props. Since we're talking about our previous example, let's go back and fix it. We first collect all the remaining props from our destructuring assignment and use the rest operator to place them in an object we call rest. Next, we spread those props on our root element with the spread operator, like so. There's one more thing to do though, because if you paid attention here as well, you might have noticed that I introduced a new bug right now. If the developer passes a class name, it will override the existing card class. And that's probably not what I want. I wanted to extend my component, not just override stuff. So to fix this, I pick out the class name prop from the props object so that it's not in the rest object. I end up spreading out. I give it a default value of an empty string, and then I concatenate it together with the existing class prop. And there you have it. Now we can pass in whatever props we want without getting into trouble. The technique works really well with the spreading of props, but it comes with a few caveats though. First, you always need to remember to combine any internal props you're adding to your component. So if you add an internal onClick handler, make sure you allow the user to send in its own onClick handler as well, and then you need to remember to call both of them. Second, if you can't combine props, you have to decide whether people should be able to override your props or if you should override theirs. And that kind of depends on the use case and mostly personal preference, to be honest with you. I like to let the end user to decide as much as possible, but that's always up to you and the situation. And third, this works best for components with a single DOM node, so it's easy to understand where the props will be placed. There are some exceptions, of course, but complex components often lead to misunderstandings and hard to understand APIs. But with these caveats in mind, though, you should remember to spread the remaining props wherever you can. Whenever you're designing a component, it's easy to get creative with the props naming. Those HTML attributes from the 1990s are so hard to type, and they often could have had better names, I guess. But I urge you, avoid renaming existing DOM attributes in your props. I'll show you why through an example. At a previous project, we created the almighty button component. It was flexible and nice looking, and lots of people used it throughout the organization. There was a few different types of buttons though, like a primary and a secondary button, and we used the type prop to specify what type of button it was. And this worked out well too, up until one developer placed a few buttons next to each other inside of a form. It turns out there is a native type prop or type attribute on the button element, which takes a value of either submit, button, or reset. And the default is submit. So when a button has a type of submit, it triggers the form's onSubmit function. And we didn't want that to happen in our particular use case. We wanted nothing to happen except the onClick event. Since we spread the props though, we didn't have a way to set both that we wanted the button to be a primary and to be a regular button. There were tons of people using our button throughout the organization, and since we didn't want to create a huge break and change for people, we did a huge mistake and introduced the button type prop. Now, this solved our problem at hand, but it created a terrible API. And even if you knew the backstory to it, it made sense, but new developers that joined the organization understood nothing. They thought we were terrible developers, which in hindsight, I guess we were. So, learn from our mistakes back then and never override an existing DOM attribute with a prop name. Even if it's esoteric and you probably won't even care about it, but just come up with another name instead. Like this API, for example, which is much easier to understand. And this goes on for tons of other types of props too. I see, for example, renaming DOM props a lot when it comes to area attributes. Like instead of just writing out area busy like a normal person would, you might write is loading or area busy in camel case. And this leads to a lot of variations across your code base probably because different people come up with different naming strategies. So it could be loading, is loading, lasted in Norwegian, or it could be a ton of different stuff. And all of that makes it hard to intuitively guess the API of your component and other components in your score of components. So instead, take advantage of the fact that you're spreading your props already. This way, you don't have to come up with names, first of all, and you don't have to write a prop type or typing for it. You don't have to add a new prop for every new area or DOM attribute that you or your consumers can think of. That's a bonus. This provides you with a small yet well-defined API that is flexible enough to rarely change at all. These 5 rules of thumb will help you create components that are easy to understand, easy to use, and easy to extend, and even easy to like. But the most important takeaway from this section is that you should design your API and don't let it be a coincidence. Design the props of your component so that they're easy for the next developer to understand and extend if they need to. The next thing I want to talk about is documentation. And documentation is a loaded word, I know. It's filled with the memories of the stuff you wrote into Confluence once and nobody ever saw again. And most of us are probably filled with bad experiences with documentation too, because it's tedious to write, nobody ever reads it, and if somebody does stumble across it, you know it's outdated. But have you ever experienced amazing docs? When done right, documentation can be a joy, both to write and to consume. Great documentation is always easily available, and available right when you need it, where you need it. Great docs are always up to date, even with that latest feature that you just shipped. And lastly, great documentation makes it easier for other developers or even future you to understand how your code works, which in turn speeds up development time and cuts down on cursing. So let's look at some ways we can make our code more readable and understandable through documentation. The most important part of documentation to me is that the documentation shows up whenever I need it. Whenever I hover a component or type it in and autocomplete it, I want the editor to tell me all I need to know. Turns out doing this today is pretty simple. Jsdoc is a way of writing comments that is easily parsable by our editor, which will show whenever you hover a component or a prop or a custom hook or a function or whatever really. And here is what it looks like. You start a block comment with 2 stars instead of 1, and you're in Jsdoc mode. Here, I've added some docs to our card component from earlier. You can write long paragraphs if you want, but a simple explanation of the what, the how, and the why usually suffices. You can even add examples. These will show up and can be great to show both simple and more advanced usages of your components. And in VS Code, at least, you even get syntax highlighting. You can also document your props, complete with deprecation warnings and aliases. And each of these prop comments will show up whenever I autocomplete any other props on that component. And that is incredibly useful. Not only does it show up just in time so I can learn just in time, but since it's co-located with your code, it should never get out of date. And it also documents your code for future maintainers. There is a lot of features in Jsdoc, and I recommend you give it a shot. Here's a great resource. I used to remember what the different keywords mean, but it also autocompletes in your editor. And don't worry about writing this down. I'll post the slides after. Sometimes you want a documentation website for devs to visit. You see this a lot with component libraries or design systems. I've made a few. You want a bit more prose about what to do and what to avoid, and you definitely want some nice interactive examples to play with. There's a few tools you can use to create stuff like that today, but my favorite is by far the Gatsby-based tool Docs. Docs is a single dependency and gives you basically all you need out of the box. It gives you a live playground editor, hot reloading for development, it parses your props and documents them for you, and it gives you a themable and pluggable design that you can customize to whatever degree you want. It works by scanning your repository or folders for JSX-enabled Markdown files and creating a statically generated website you can host wherever. That means you can co-locate your Markdown documentation with your code as well. Another added bonus is that it parses your Jsdoc comments and shows your inline code comments in an easy-to-read format on the web. This is a huge bonus because it means that you, in order to be both on the web and be documented in the code, you need no documentation duplication whatsoever. This is how it looks by default, by the way. It even ships with dark mode if you want that. It's a great way to create more in-depth documentation too, which can come in handy for some of the more advanced components you put together. Another way of documenting your code is creating really good error messages and warnings that show up in the console while developing. This comes with a few upsides. First of all, it helps people new to your code base to use your code correctly. So if they consume a context without wrapping your app in the correct provider, or if they've passed in an illegal combination of props, or if they're using a deprecated feature, they can be told why stuff doesn't work in full sentences. Perhaps you can even link to a custom page in your Docs documentation website that goes into more detail about what one should do and how you solve deprecations, for example. The second nice thing about dev-only warnings is that they live with your code. They are code, I guess. So code doesn't get outdated the way documentation does. It gets removed or refactored away. So thus, the warnings are never out of date. People reading the code can understand why something goes wrong, which is also a huge plus. Finally, if we're worried about the bytes here, you can tree shake all of these warnings out when you're building for production. That means 0 added bytes to your app, yet a much better user experience for the developers. Documentation is key, and it doesn't have to be boring. It doesn't have to be outdated, and it doesn't have to be left unread. Focus on placing most of your documentation inside of your component files, next to your code. Use Jsdoc to integrate it with your editor. Use use Docs to create interactive documentation websites. Use dev-only warnings to document edge cases, deprecations, and misuse. And remember to link to relevant documentation sites in your dev-only warnings as well. The end result is that your colleagues will love reading your code. You put their need for information first while providing it to them just in time. So, we've learned some ways to create well-crafted props for our components and looked at how we can document their usage. The last part of the puzzle to create truly compassionate components, at least to me, is to build trust. We need to trust our components. But what does it mean to trust your components? In my eyes, you need to be confident that the components works as intended. And that means no bugs, edge cases covered, it's both usable, it's accessible, and I can test the component and all its test cases manually, but I'd rather have software do it. Also, you need to have a strong sense of confidence if you're ever to refactor your code. Again, you could solve this by full regression tests all the time, but those they're expensive and impractical. So we need to be confident that we've done a good job implementing stuff before we ship it to our users. But what's the best way to get there? Writing tests for front-end code used to be a nightmare. There was shared state a lot of times between the tests. The feedback loop was always really, really long. And we wrote an amazing amount of unit tests. Today, the situation is pretty different. We have tools that help us write better code. The test runners have become much more developer-friendly. But we still tend to test implementation details through a lot of these unit tests. In this last section, we'll look at how you can build trust in your components while not getting in the way of a good developer experience. There are lots of problems that we can use existing tooling to find and report for us. I mean, us as developers, we're obviously pretty smart, but machines can be pretty clever too. If a program can analyze our code and find bugs for us, we can do more useful stuff with our time. The most popular tool for analyzing our code these days is ESLint. And a linter like ESLint can spot pretty advanced bugs and fix them sometimes. It could find potentially infinite loops, or it could find like a missing dependency in your use effect, or a missing area label in your icon buttons, for example, or just code smells in general. There are tons of ways to set up ESLint, but the defaults that ship with Create React App is usually more than enough. If you're not using Create React App for your app, you can use its predefined rules with extending their config in your ESLint config, and then just add or remove whatever you don't like. ESLint has saved me from shipping so many errors, and it helps you avoiding testing the kind of bugs that they fix. There's another type of static analysis which is particularly helpful when creating React applications, and that's static type systems. As you probably know, JavaScript is a dynamic language with no built-in type system. This provides us with a lot of flexibility when it comes to solving challenges, but it also doesn't provide any safety net at all. That worked back in the days when you only had to do a few minor things in JavaScript, but in today's application world, that's kind of not good enough. The result is that we have to ensure our code can handle whatever input we throw at it, leading to the need for lots and lots of unit tests, which in turn sucks. Instead, we can use type systems like TypeScript or Flow, or more likely TypeScript, to type our interfaces. Here's an example of the props passed to our button component earlier. We can specify the type of arguments and check that the code calling our components are doing it correctly. Compile time. And this way, there's no way to misuse the API, and you get a really nice and tight feedback loop. And a little side note, TypeScript or Flow used to be really hard with React, but in modern React with custom hooks and stuff like that, it's really as easy as you can think of. I was super afraid of it, and it turned out to be really, really nice. So if you haven't given it a shot, give it a shot. There's actually tons of potential upsides to use in using a type system like TypeScript in your code right now. I won't go through them all in detail. It's an hour-long talk in itself. But my favorite ones are that it's much easier to discover what's available in an API. You get this great auto discovery and auto completion. It also replaces most of your unit tests with actual code. And finally, it makes refactoring so much easier because you can programmatically refactor stuff without having to remember all of the stuff that you need to change the name of. So consider introducing types to your code base. You can do it gradually if you want, and there are tons of great resources out there to get you started. Another thing I want you to remember about testing your React components is that you should avoid testing implementation details and test the stuff like your users use your component. By doing this, you'll have much more sturdy unit tests, which won't break whenever you do a refactor. And you'll test that stuff will work for your actual users and not just in your test suite. But how do you do that? Well, first off, I suggest you throw away whatever you're using today and start using React testing library. It's made by the testing wizard of Oz, Ken C. Dodds, and it helps you interact with your code like your users do. Next, you should test your components only through their props. By that I mean never manipulate internal state or call instance methods on class components. Instead, just re-render your app with different props and verify that the right things are rendered. And finally, you should assert that your components work by asserting on visible output rather than class names or IDs. React Testing Library has a ton of great selectors to do this for you. And as a bonus, you can actually use accessible selectors to improve the accessibility of your code as well, through getting stuff by role, to remember that you have to have different area roles, for example. Finally, I want to suggest that you try to write broad tests that covers most of your components. If you're testing on an app level, aim for writing integration tests that tests complete vertices of your app. By doing this, you can write much less tests. A few tests will cover huge parts of your code and provide important documentation of happy cases, edge cases, and errorness cases. So these are some of my best tips when it comes to making both yourself, future developers, and consumers trust your components. And trust is important when you're building code other people will use. Without it, we second guess every decision made, even if they were made for a particular reason. To me, code is communication. Code is the language we speak with our fellow developers and the way we communicate our intent. So if you don't remember to communicate in a compassionate way, considering the needs of the recipient, we'll end up writing code that's hard to understand, tricky to extend, and often end up being replaced in the long run. Instead, I suggest that you'll consider some of the tips in this talk to improve that communication. First of all, you need to put some thought into how you structure the props of your components. This will help make your components intuitive to use while making them easy to extend. Creating a good set of props doesn't even need to be that hard if you just follow a few simple guidelines in some talk. You need to create documentation that shows up when you need it. This will make your components much more usable by the end user. In addition, it will help future maintainers, and that includes you, to understand your code better. Use static analysis for what it's worth. You can do a lot less testing by just adding a linter and a type system, and a lot less writing at that. Providing a type system is a particularly helpful way of avoiding bugs while improving API discoverability as well. And when you test, make sure to write wide-reaching tests that use your code like your users do. This provides you with a lot of confidence when you refactor or otherwise change your code in some way. In addition, you don't have to do a lot of manual testing before you go into production. And finally, take a big step back. Try to envision other developers using your code, because when you empathize with their needs and wants, you're showing them compassion. And when you make sure you code for other people, those other people will end up loving your code. That is my talk. thanks a ton for watching. I'll be in the Slack channel answering all your questions if you have any.